right. All right, well, we can start. So thank you everyone for joining this session. This session will be recorded. We have Chris from Consensys, who is going to speak about how to break a smart contract, common security vulnerabilities. Feel free during the workshop to send any questions you have in the Q&A section, and we will try to answer those at the end. All right, Chris, you may go ahead.
Sure. Yep. Good morning, everyone from Portland, Oregon, or good evening in CST. Today, we're going to talk about security vulnerabilities, specifically a reentrancy attack. So we're going to walk through how it happens, and then during the workshop, we're actually going to attack a smart contract with another one, using that vulnerability to exploit the victim smart contract and drain the balance. So we're going to be doing a little live hacking here. If you've seen the show Breaking Bad, this is kind of a tribute to Breaking Bad, except we're breaking Ethereum. It's a little fun. So my name is Chris Annatalio, and I'm a platform advocate for Infura. Infura provides blockchain infrastructure for Ethereum and other L2 blockchains, such as Optimism, Arbitrum, Polygon, as well as support for IPFS and Filecoin. We kind of abstract away the complexity of running an Ethereum node so you could focus on your smart contract development. Okay, so now we're going to look at some code, and we're going to look at a vulnerable smart contract. So here we have a solidity function, right? Pretty straightforward. Basically, we want to, it functions as a bank. You can deposit Ether, and then you could withdraw it. So let's take a look line by line. First, we have a mapping that keeps track of everyone's balance. So we check if they have enough Ether in their account to withdraw the requested amount. And then we send the value to the caller. And then we update the balance in the mapping. So, I mean, that's pretty straightforward, right? So let's look at that vulnerable Etherbank contract next to another smart contract, which will actually try to exploit that smart contract. And this code is kind of simplified for brevity, so it's easy to read, but we're going to go through some actual code later in the workshop when we do the live hacking. So basically what happens during a reentrancy attack is you have, so you have your attacking contract, and it calls the withdrawal function. So it's normal. So you want to do like 10 Ether, this would be like 100 Wei, but just try to keep the visual simple. So you call the withdrawal function, and then after it checks your balance, it'll actually call back to your anonymous fallback function. But in this case, it was maliciously overridden to recursively call the withdrawal function again. So within that same invocation, you're calling withdrawal like repeatedly in like a recursive loop. So basically, instead of withdrawing 100 Ether, for instance, you would drain the account. So you would call the function over and over until the Ether bank was drained of all funds. in this anonymous fallback function, like in the actual code, you need a boundary condition, or else this will iterate infinitely and crash. But this is just like the basic gist of a reentrancy attack. So it's actually pretty simple, and it's really scary. You totally drain all the value out of a contract. And if you've been around the ecosystem for a while, this is what happened during the Ethereum DAO hack. So basically what caused the hard fork between Ether Classic is basically a similar attack. A reentrancy attack was used to drain a DAO, I believe, of all its Ether. And they had to hard fork the entire blockchain because it was such a traumatic attack. So this type of attack isn't as much of a issue nowadays because people have learned how to deal with it, just because it's such a dangerous thing. So basically, the simplest way to defend against it is just a slight change in logic. So you wrap your balance check in an if block, and then when you make that call to the anonymous fallback function on the calling contract, you actually validate those return values, which prevents that infinite recursive loop of reentrancy. So yeah, it's pretty simple change. You see that extra require call, but otherwise the logic is pretty similar. So in this case, in this updated smart contract that's designed to prevent a reentrancy attack, same flow. The attacker tries to call the withdrawal function. It's overridden the anonymous fallback, and it's trying to initiate that attack, but it gets defended because of that require statement. So you only withdraw the original, like 100 Ether, for instance. So that's basically it in a nutshell at like a basic level. In like the real world, there's a lot more nuance and trickery, if you will. There's a lot more. It's almost like an arms race, people defending against attacks versus people coming up with new exploits. So yeah, it just always be very aware and cognizant of all the newest security recommendations. Get your smart contracts formally audited. You could use something like Diligence for like fuzzing and static analysis for like common security issues. I think MythX is also another security platform. But yeah, so now we are going to move into some actual live coding. So if you guys want to follow along here in the workshop and get your actual local dev environment set up, if you're already set up with Truffle and MetaMask, then you're good to go. So this is a QR code. If you want to scan that, if you need a wallet, MetaMask is a browser-based wallet for Ethereum and EVM compatible blockchains. So if you need that, just go ahead and go to metamask.io/download. Like I said, I work for Infura as a platform advocate. If you want to deploy to testnet, you get a free account in Infura and deploy to several test nets for free really easily. Truffle also has a VS Code plugin, which helps you deploy to testnet as well. And then, so we're going to be using Truffle for managing some of the compilation and migration of smart contracts. And then if you're going to deploy to testnet, you're going to need some test ETH. So you can check out this faucet app.mycrypto.com/faucet if you need some test crypto. And then the actual code for the workshop is on GitHub. If you scan this QR code, it'll bring you to the repo, and you can pull down that code. It should be fully functional. I just tested it. So yeah, if you pull down that code, you should be able to follow along locally and hack your own smart contract on your local machine. And if you want to follow me on social media, here's one more QR code. You can scan that, and you can link up with me on Twitter, on our Discord. Consensys has a Discord where we offer technical support. So I think we will be setting out these slides as well. If anyone needs any of these links, again, just ask me a question in chat, and I'll provide it for you. So now let's get into the live coding section. Cool. So this is VS Code. I hope you can see the code. Sometimes on these tutorials, the font is too small. So let me see if I can. There we go. Cool. So here is, so in the presentation, I showed you some like snippets of these contracts, but here are the full contracts that actually compile. So basically, in this Ether bank, you have like a mapping that'll map the address to the balance. You have deposit and withdrawal functions, and then just a read-only view function to look at the balance of an address. So pretty straightforward, but it does include that vulnerable code. So we are going to be executing a reentrancy attack against this contract here. So on the attacking contract, basically when in the migration script, so we pass in the address of this Etherbank deployed contract, so that we can call Etherbank from our attacking contract. And yeah, so basically you have initial deposit so that you can pass this balance check here. And then this attack function here, when you withdraw 10 Ether, it'll call this function here. And like I said before, this line here will call back to this anonymous function here, where the reentrancy attack happens, and it loops through, and basically it'll keep calling this method over and over until the victim, the deployed Etherbank contract, has a balance less than or equal to 10. So it's basically going to drain the contract. So let's go ahead and get this going. Yeah, and if anyone needs help with their local setup, just ping me on chat. So first, so let me get into my project directory. Here's my node. And then let me run Ganache here. So Ganache is a part of the Truffle tool suite. There is a CLI library, which is the NPM library, which you could install. So I installed Ganache globally via NPM, and basically it'll spin up a local instance of the Ethereum blockchain, right? So if you want to work with it in a web browser, you would enter this mnemonic into your MetaMask. So let me see. Yeah. Let me go ahead and do that so I can fund the Etherbank victim contract with some money so that we have some Ether to drain out of that contract. So let me open up my MetaMask. Yeah, if you're wondering why my MetaMask is purple, this is like the bleeding edge like dev version, which has some experimental features. But yeah, of course, don't ever expose your seed phrase. This is just local. But yeah, just bear with me as I enter in this stuff. Cool. Yes. So Ganache by default gives each account 1,000 ETH. I wish that was real ETH. That would be like 3 million. I don't even know what the price is now. Probably 2 million. But yeah. So that's configurable. You could set the number of accounts generated, the base account ETH. But yeah, so let me see. So now I am in my project directory. And what I'm going to do, I'm going to use a Truffle toolchain to compile my smart contracts. Basically, you get the ABI or the JSON format of the compiled contract, and then we can migrate that and deploy it to our local blockchain. So first, let's compile. And then on my Truffle config, I configured my local Ganache so that it's able to deploy my smart contracts. So here's the attacking contract, and here's the Etherbank. So let's grab that deployed contract address. And let's send some Ether to it. Send them 90 Ether. Okay, and so we sent the Etherbank contract some Ether. So now let's open up a Truffle console shell. So basically what the Truffle console shell allows you to do is you basically have access to the web3.js library. So you could interact with a smart contract, just like if you had like a front end. You know, if you had a UI front end, that would use web3.js to talk to your contract. But here we're doing it on the command line. So first off, let's get a instance of the Etherbank contract. So this is basically just an async call saying when it's deployed, give me that deploy contract instance. So we can check the address here, and we can see this address, B31B. So we can see that, so that looks right. So now let's grab the attacking contract. Then check that. Okay, cool. So now what should we do? So on Etherbank, we're going to do, I created this convenience method where basically we can update the mapping and create a balance for the attacker. So we're going to call the initial deposit function on Etherbank, and we're going to pass in the address of the deployed attacker contract. Well, you can see this actually initiated a Ethereum transaction. Now let's check the deposit, or let's check the balance of that attacker's address. So let's grab the balance. So this is a big number format where we can convert this using Web3. But it's actually not important. So now that the attacker actually has a balance, so if we go back to the code, so basically what we did is we called this function, which basically just updated the mapping, saying that this deployed contract has 10 Ether, so that it'll pass this validation here. So now I'm going to go ahead and call this attack function, and if we didn't attack this contract, it would just pull out 10 Ether. But because we're doing this this hack, it's going to drain the contract, and this contract should have 90 Ether in it. Let me double check that. Let's see. So if you go to the repo, I have all these commands I've executed here. If you want to go through later and do them yourself, basically this command will let you get the actual balance of the wallet behind the smart contract. You know, like in Ethereum, you know, you have externally owned accounts, which are like a wallet owned by a person, and then you have wallets which are controlled by smart contract code. So let's get the current balance of the attacker contract. Okay, so yeah, so the attacker currently is at 0, which is to be expected. And then this is a way, but yeah, if you recall, so we sent that contract 90 ETH, right? So now, yeah, we verified that there's 90 ETH in the Ether bank to drain. So now let's call the attacking contract instance. And let's see what happens. So, yep. So, I mean, like the transaction went through just fine. It was really gas heavy because we had a lot of those recursive calls. But yeah, it went through just fine. So now let's check those balances again. Oops. Yes, I already declared that variable. Oh wait, I might have missed something here. Okay, give me 1 second. Let me parse through. Did I miss something? Attacker, attack. I just ran through this exercise. So attacker, attack. Take a look at the code. If the code Let me take a look at the Ganache logs here. So let's see. So I did the attack. Balance. Let me restart my console and try that one more time. Let me make sure the most updated versions of the contract were deployed here. Okay, so let me try this one more time. So my Truffle console. Let me grab my contract instances. Okay, I'm sorry, guys. I think my blockchain got desynced between the console and let me see. But yeah, let me just try redeploying these contracts. Oh. Etherbank. Okay, so let me double check the addresses again. Okay, and then Etherbank. Bank address. Okay. Okay, so now let me send that deploy contracts in ETH again. So we set it at 100 ETH. Probably should have paid more gas to speed it up. I may have forgotten to update this variable, the balance, beforehand. So let me try it. Okay, cool. So now let's try this again. Ether bank dot. Let's create an initial deposit. Cool. So now I'm going to check the balance and the mapping in the Ether bank. Hit balance. Okay. So it has 10 ETH in the mapping. I'm missing anything? Okay, so now let me call the attacker. Call that attack function. Now let me grab the balance. Well, let me update the balance of Etherbank and the attacker contract. So we could see the attacker balance now has, well, this is denominated in Wei. So basically, this whole 100 ETH that we sent to Etherbank was now drained by the attacking contract. So basically, this attacker normally the Etherbank was like, okay, so you want 10 ETH. Let me check your balance. Okay, you have 10 ETH. So I'm going to go ahead and send that to you. But then because we did a nasty little hack, instead of withdrawing 10 Ether, we withdrew the entire contents of the contract. So let me see. So yeah. So if we look at the deployed Etherbank balance after we updated the actual balance of that contract, yeah, we pretty much cleaned it out. They have zero Wei. They don't even have dust. Like not even a single drop of ETH. We took it all. So yeah. So I mean, I guess it's not that sophisticated an attack. You know, it's like. I mean, obviously, in the real world, you would need a more sophisticated contract to actually, exploit a live mainnet, contract that's been audited. But it's kind of terrifying that such a simple technique is able to drain an entire smart contract. Like imagine if you have a DeFi company and you have tens of millions, hundreds of millions of ETH and ERC20 tokens in your wallet being actively managed by your DeFi platform, and one day you wake up and the balance is zero. It's it's pretty scary. So Did anyone have any questions? Yeah, Gloria. I did resolve it. I think I just forgot to update these variables when I rechecked them. So after I did that, the balances were correct. Yeah, so I've been talking like straight for 45 minutes. Did anyone want to ask any questions? Did you want me to dive more into something? Did you need any additional clarification? Oh yeah, thanks for the help, Philippe. Yeah, I was checking the chat for questions. Yeah, I mean, I could also show you. I mean, this could also be executed from the front end. So. So yeah, so I'm just trying to keep up on the Q&A. Let me see. Yeah, this is an old vulnerability, but it is a classic. Yeah. I mean, I was expecting there to be some more questions, but so I mean, that's about all I have.
Yeah. All right. Chris, let me see if there's any questions real quick. Yeah, I don't see questions. I think that some people have been exposed to this and some people haven't. So I really appreciate you going through and like kind of showing these vulnerabilities. Let me see if there's any questions in the YouTube stream at all. Yeah, I don't have any questions. I think I have an overall question just in general, Chris. So I know that when it does come to threats and vulnerabilities, especially within blockchain spaces. We really, as developers, have to be very keen on like what's going on and keeping up to date, because we need to write really clean code. And from that perspective, like, what do you have anyone who you would recommend, like, if this is something that's interesting for people, or like going deeper in different threats and vulnerabilities that people should follow or like look into just to keep in the know?
Yeah, definitely. Let me see. So we have this service called Diligence, which basically is like an automatic way for scanning your contracts for various security vulnerabilities. So it could kind of be part of like your deployment pipeline to automatically scan for vulnerabilities. You know, we provide fuzzing and some other services, as well as formal audits. Like Open Zeppelin, of course, is like they like, as far as like base contracts, they're audited and battle tested, and they also do formal audits. But yeah.
Awesome. So really just going back to the Truffle suite of tools and seeing both Open Zeppelin and Diligence would be a good start, per se.
Yeah.
Awesome. Yeah. I don't see any other questions in the chat or in the Q&A. So with that, I just would like to thank you for your time. And for those who are participating, I would strongly suggest looking back into the Discord for the upcoming workshops. I know that there are a couple happening in a couple days. I know that the summit is kicking off here, I think, on the 20th. And there's a lot of great panels and talk there as well. So thank you so much for everyone who joined us, and we will see you again next time. Bye, everyone.
Thank you.